Today we are going to see the Schrodinger equation, which is time independent. We have already seen the time dependent Schrodinger equation. What is the basic difference between the time dependent Schrodinger equation and time independent Schrodinger equation? See, in the time dependent Schrodinger equation is the general form of Schrodinger equation that describes time evolution of the wave function for a quantum system, including the position and the time factor. Whereas, on the other hand, the time independent Schrodinger equation is the simplification of time dependent Schrodinger equation, and it is dealing with only the spatial part of the wave function, and it does not depend on the time factor. That is why it is called the time independent Schrodinger equation. It has got another name, that is Schrodinger equation in its steady form. See, in great many situations, the potential energy of the particle does not depend on time explicitly. Therefore, the force that is acting on the particle will vary with respect to position only and not on time. Therefore, the Schrodinger time dependent equation can be simplified into Schrodinger time independent equation by removal of all time factor in it. Now we write the unrestricted particle equation. Do you remember this equation? This equation we have already used while deriving the Schrodinger time dependent equation. That is psi is equal to a e power minus I by h cross et minus px. What is this equation? This is the equation of the unrestricted particle, which is having energy E and momentum P and moving along the positive x direction. Now this equation can be written as a e power minus IE by h cross into t e power IP by h cross into x. Now this position dependent function can be replaced and written as psi. Therefore, psi is the product of the time dependent function exponential minus IE by h cross into t and the position dependent function psi. Now we are going to substitute the value of psi that we have just derived into the equation which is time dependent. E psi is equal to p squared psi by 2m plus v psi. Now we know p squared psi is equal to minus h cross squared dou squared psi by dou x squared. So in the place of psi in this equation we are going to replace psi e power minus I e by h cross into t. Therefore the equation becomes e psi e power minus IE by h cross into t is equal to minus, put the value of p squared psi here. So it is minus h cross squared by 2m e power minus IE by h cross into t dou squared psi by dou x squared plus the potential energy term u or v psi e power minus IE by h cross into t. Now we are going to divide the entire equation by the common term, and we are going to multiply the 2m multiply the equation by 2m by h cross and going to rearrange the equation. What is the common term in all this equation, all the terms? It is e power minus I e by h cross into t. Therefore, when we divide by the common term and multiply the equation by 2m by h cross squared and rearrange and write the equation as written as dou squared psi by dou x squared plus 2m by h cross squared e minus u into psi is equal to 0. So this is the steady state Schrodinger equation in one dimension, and this is it does not have any time dependent term in it. Therefore, it is called the time independent Schrodinger equation. In 3 dimensions, this equation can be written as dou squared psi by dou x squared plus dou squared psi by dou y squared plus dou squared psi by dou z squared plus 2m by h cross squared e minus u into psi is equal to 0. Now we can derive the same Schrodinger time independent equation in another way, that is using the operator's form. We know the total energy is equal to kinetic energy plus the potential energy. Now, in using the operator's term, it can be written as E cap is equal to kinetic energy cap plus U cap. Now, the potential energy, most of the time we said it does not vary with the time. Therefore, the total energy is constant and the operator E is simply a number E. The potential energy, as before, capital V is equal to, that also is does not vary with the time, so it is V. The kinetic energy operator is equal to P squared by 2m, where P is representing the operator term, and it can be written as 1 by 2m, that is already in the expression, and P operator has the operator expression h cross by I dou by dou x, and it is square term, therefore the whole square. Therefore, the kinetic energy operator is minus h cross squared by 2m dou squared by dou x squared. Now substituting this in the total energy term, we have E is equal to the kinetic energy term plus the potential energy term. So it is written as E is equal to minus h cross squared by 2m dou squared by dou x squared plus V. Now we multiply throughout the equation by psi. So we get E psi is equal to minus h cross squared by 2m dou squared by dou squared psi by dou x squared plus V psi. Therefore, when we rearrange this equation and write as dou squared psi by dou x squared plus 2m by h cross squared E minus u into psi is equal to 0. Now this is the Schrodinger equation in time independent form, that is in steady state form. Now you know, students, how to derive the Schrodinger time dependent and time independent equation. We will meet in the next class. Thank you very much.